CloudCasa now partners with HPE. In this video, we will walk through a complete CloudCasa backup and restore cycle for a stateful PostgreSQL application running on HPE Kubernetes Service, managed through Morpheus, with backups sent to HPE StoreOnce. The CloudCasa agent is pre-installed on the cluster. A backup job targets the Postgres namespace and sends data to an HPE StoreOnce SMB target. A restore is then performed to a new namespace on the same cluster with full data integrity verification via the PostgreSQL CLI. We will start our demo inside Morpheus, HPE's cloud management platform. Here you can see the Kubernetes cluster we are working with today, MorphDev Cluster 1. It's a Kubernetes cluster type currently showing a healthy OK status with 4 hosts, 0 alarms. We have navigated to the Control tab. Notice the namespace dropdown is set to CloudCasa IO. This is the namespace where CloudCasa's agent components are running. We also have the CloudCasa Software as a Service portal open in a separate tab. Running kubectl getAll against the CloudCasa IO namespace confirms the CloudCasa agent is healthy. You can see CloudCasa KubeAgent Manager and the KubeAgent pod both in running status. This agent is what connects this cluster to the CloudCasa service and orchestrates all backup and restore operations. Now let's switch to our SSH terminal and verify the PostgreSQL application that we will be protecting. Running kubectl getAll in the Postgres namespace, we can see a single pod running, along with its service and deployment. Everything is healthy and up to date. We will exec directly into the Postgres pod and open a PSQL session as the admin user. You can see we are running PostgreSQL 15.17 on Debian. Running the /l command lists all databases. We can see our target database, testDB, is present here alongside the system databases. This is the database we will be backing up and later verifying after restore. Connecting to testDB with /c testDB and running /dt+ to list tables. At this point the database exists but it's empty. No relations yet. We are about to create a table to give us something concrete to validate after the restore. We create a user table with 3 columns. And we insert 2 rows, Bob with bob@example.com and Charlie with charlie@example.com. These are the records we will confirm are present after the restore completes. Switching over to the CloudCasa portal, we are in the cluster section and have opened an existing backup definition called demo SMB stateful. Let's walk through its configuration. The backup is configured against our HKS cluster. We are protecting selected namespaces, specifically the Postgres namespace, and persistent volumes are set to copy to backup storage, which means the actual PVC data will be captured and transferred to our target. No scheduled policy is attached. We will trigger this manually. The backup job is named demo SMB stateful. The SMB here refers to our HPE StoreOnce target mounted via SMB. We have the configuration and will trigger it now. CloudCasa confirms the backup job has started. In the activity log, we can see the new entry at the top, message checking access to file store, StoreOnce SMB, which means CloudCasa is validating connectivity to the HPE StoreOnce target before streaming the backup data. Back in Morpheus, we can see real-time evidence the backup is running. A new pod, ccfs deploy, has just appeared in the CloudCasa IO namespace with an age of only 14 seconds. This is the file store deploy pod that CloudCasa spins up dynamically to perform the data transfer to StoreOnce. Drilling into the activity details, we can see this is a Kubernetes copy job type. This message already shows backup successful. CloudCasa has finished the snapshotting the namespace resources, and the persistent volume data stats confirm 69.28 MB estimated, 41.34 MB read, and 21.96 MB transferred to StoreOnce. The backup job is now fully complete. total duration was 1 minute and 24 seconds. The persistent volume snapshot stats confirm 1 snapshot taken, 1 completed and 0 failures. We have a clean recovery point stored at HPE StoreOnce. Now let's perform the restore. We navigate to the Restore section and click Define Restore. The wizard opens at the Source Clusters tab, where we select our HKS cluster as the source, the same cluster the backup was taken from. Its status shows active. We select the recovery point from the backup we just ran, timestamped 5/15/26 at 7:09. This is the most recent recovery point available, capturing the Postgres namespace with our user stable and data intact. On the Select Resources tab, we are restoring the Postgres namespace. Persistent volumes are included, so the PVC data will be restored alongside the Kubernetes resource definitions. For the destination, we select Use Existing Cluster and point it back at the HKS cluster, the original source. This is the same cluster restore. To avoid namespace collision with the live Postgres namespace, we will apply a rename transform in the next step. In the Restore Transforms tab, we enable rename namespaces and choose Add Prefix Postfix. In the suffix field, we type restored. This means the Postgres namespace from the backup will land as Postgres restored in the cluster, completely isolated from the live Postgres namespace already running. The summary step shows the full restore configuration: source cluster, HKS cluster, backup, demo, SMB, stateful. Recovery point from 7:09 p.m. tonight, recovery point size 69.28 megabytes, namespace suffix restored, run now is toggled on, we click save and restore. CloudCasa confirms the restore is underway. The new entry Postgres restored new appears at the top of the restore list, associated with HKS cluster and showing selected namespaces. The activity detail confirms all restore parameters. Job type is restore, currently running. It's pulling from the demo SMB stateful backup at the recovery point we selected, sourcing the data from StoreOnce SMB. The In Progress panel shows 27 seconds elapsed and confirms CloudCasa is actively reading from the StoreOnce SMB file store to stream the backup data back into the cluster. The Restore Job Detail page confirms the end-to-end configuration. Source and destination are both HKS cluster, the restored suffix is applied, and the job has been running for 42 seconds. With the restore complete, let's jump back to Morpheus and run kubectl get ns to see the full namespace list on the cluster. And there it is. Postgres restored is now listed as an active namespace alongside the original Postgres namespace. Both are present and healthy on the cluster. The restore has landed exactly where we expected. Switching the kubectl namespace dropdown to Postgres restored and running get all. We can see the Postgres pod is running with an age of just 44 seconds, confirming this is a freshly restored instance. We exec into the pod in the Postgres restored namespace and open a PSQL session. Running the /l confirms testdb is present in the restored instance. We connect with /c testdb, then run /dt+, and we can see the users table has been fully restored. One table, 16 kilobytes on disk, permanent persistence. And the final proof, select all from users returns exactly the 2 rows we inserted before the backup, Bob with Bob at example.com and Charlie with Charlie at example.com. The data is completely intact, confirms a fully successful end-to-end backup and restore cycle. That's CloudCasa backup and restore for HPE Kubernetes Service, protecting a stateful application to HPE StoreOnce and recovering it with full data integrity. If you want to try it yourself, head to CloudCasa.io and get started for free. If you're an HPE customer and want to see how this fits your environment, reach out to us directly and we will walk you through it.